Monte Carlo is an approximation method based on sampling. And typically, the things which we are interested in approximating are going to be difficult, intractable sums or integrals. So in this video, I'd like to tell you a little bit about the history of the Monte Carlo method, because I always find the history of mathematics and science to be fascinating. So in this video, we're just going to talk about a little bit about the history, and then we'll get into the mathematics. The idea behind Monte Carlo approximation is extraordinarily simple. It's trivial in some sense. And so the idea has, I'm sure, has been around for ages, but it really only started to take its modern form and in terms of people really developing the mathematics of Monte Carlo methods in the 1940s. So this is these are some giants of mathematics and science here. This in the middle is Enrico Fermi, and Enrico Fermi was he was a physicist. He was an Italian physicist, and he was a brilliant physicist. Fermi won the Nobel Prize for Physics in 1938 at the age of 37. Very young winner of the Nobel Prize for his work in radiation. And Fermi was doing Monte Carlo. He was doing Monte Carlo approximations by hand. Well, sort of by hand. He would Fermi. The stories go, as you know, as the stories are told of Fermi, what he would do. Sometimes what he would do is when he was going to run an experiment, he would use his calculator. He had a little calculator, and he would run Monte Carlo simulations to try to estimate the outcome of the experiment. And then he would tell his colleagues of his predictions, and amazingly, he was often very close. His estimates were cannily accurate. So Fermi was doing this probably in the 1930s. And but as you can imagine, it must have been extraordinarily tedious to do these Monte Carlo simulations, getting tons of samples by hand and doing these calculations. So this method did not really catch on until in the 1940s. This over here is John von Neumann, and von Neumann was, well, he was an extraordinary mathematician, both applied and pure, and one of, I mean, perhaps, one of the greatest mathematicians in the 1900s. But one of von Neumann's obsessions was computers, and von Neumann built some of the first computers. So von Neumann was, you know, among many other things he was doing, he was building computers in the 1940s, designing and building computers. And so in the mid 1940s, von Neumann and Fermi and Ulam, they were all at Los Alamos working on the bomb. So von Neumann had his computers, and Fermi was there doing physics, and Ulam, this is Stan Ulam over here. They were all at Los Alamos, and they were working on the bomb, and that was in the 1940s. So, of course, I mean, the atomic bomb, was a terrible technology. I mean, resulting in the death of many, I don't know how many people in Japan. And so that was very unfortunate. But it turns out that they ended up doing some good science there while they were at Los Alamos. And in fact, it was after even after the war was over in 1946, Stan Ulam, who was he was a mathematician, and Ulam, he was one day he was sick. This is the story he tells. He was sick and he was playing solitaire, and he wanted to estimate, or he wanted to calculate the probability of getting a perfect hand in solitaire or something like that. So it was something along those lines. and he couldn't do it analytically. I mean, being a mathematician, I'm sure he wanted to calculate this analytically, but he couldn't figure it out. And so it occurred to him, and he might have been, he maybe sort of in the back of mind thinking about Fermi's Monte Carlo approximations. He said, I wonder if we could you know, use an approximate method. Just what if what if I could just, you know, sample a bunch of deals from the deck of cards and count how many times how many times it's possible to get a perfect hand. And so that got him thinking more and more about, well, hey, von Neumann's got these computers and they're super fast at calculating. So I wonder if we could actually use this sampling idea on more interesting problems, more real scientific problems that were extraordinarily difficult to solve, and they were trying to solve some of these problems at that time at Los Alamos. Some real hairy physics problems. And so Ulam talked to von Neumann and other people, and they developed this idea of Monte Carlo approximation. I mean, of course the idea had been around for a long time, but they developed sort of they turned it into something which was actually a practical method because of the possibility of running many simulations on von Neumann's computers. So really, I mean, these guys sort of get the credit for Monte Carlo, but that's only in some sense because they had computers, because, well, von Neumann and others also had developed fast computers. And I'm sure, the idea was certain to come around eventually, that once you had computers, and these were sort of the first guys to really get their hands on these computers and be working on some real difficult, challenging scientific problems. But the idea was certain to come around eventually that, hey, we could use these computers to do fast simulations and approximate quantities which are difficult to compute analytically. So that's the history. Oh, and of course, the name. Why is it called Monte Carlo approximation? Well, as the story goes, Stan Ulam, this is Ulam, Ulam had an uncle who liked to go to the Monte Carlo casino in Monaco. This is a picture of the Principality of Monaco. And it is bordered by France. As you can see, it's on the coast. And it's bordered by France, and Monaco is the smallest, well, it's not the smallest, it's the second smallest by area, the second smallest country in the world, second only to Vatican City. But Monaco is world renowned for its luxurious Monte Carlo casino. Monte Carlo casino. And Ulam had an uncle who loved to go to the Monte Carlo casino and blow all his money on the games of chance. So they named it after Monte Carlo in honor of Ulam's gambling uncle. And I think it's an appropriate name. It captures sort of the flavor of what's going on, and it's a catchy name. Okay, so that's sort of the history of the Monte Carlo methods. And after that, many, I mean, sort of starting around this time, these brilliant guys started really thinking hard, and others as well started really thinking hard about how could you turn this and how could you improve the sort of basic Monte Carlo method and all sorts of variations on it. And so it really sort of took off from there. Okay, so that's the history, and next we'll take a look at what Monte Carlo approximation is.